Hello everyone, welcome to the Ethereum Engineering Group meetup. So today Brett is going to talk about Ethereum 2 and where we're up to with that, where we're going as well. And so thank you for doing the talk today, and so please take it away.
Excellent, thanks everyone. My name is Brett Henderson. I work with the Pegasus team. We developed one of the Ethereum 1 clients. I'll use the word Ethereum 1 versus Ethereum 2 throughout this, Ethereum 1 being mainnet as it is today, Ethereum 2 being what we're going to talk about today. And if all goes well, this will start working. So this is the second of the presentations I've done. The first one I did in September last year, which is available up there if you want to look at it. It goes into where we were at in September last year with Ethereum 2. A lot had happened in all of 2018 that led to this thing finally starting to solidify. There's a lot of detail in that particular presentation that's about the actual individual components. This presentation, while I'll touch on some of that to make sure we've all got a common understanding, I'm not going to dig into the depths of some of those that I did in that one. The other one that I did earlier this year, which was Ethereum 1.x, again, there's some elements to that commonalities between some of these things. You'll hear me talk about some pieces that are in both. Again, I'm not going to dig into the details on that, but Ethereum 1.x was very much around how do we maintain Ethereum 1 or mainnet as it is today until Ethereum 2 comes online. Interesting. So what I want to talk about today is what is Ethereum 2? So again, bringing us to what is the current definition of what Ethereum 2 is, to talk about the phases for the delivery. So since I talked last time, we've started to, within the community, define the phased part approach for delivery and where they're at. And then finally kind of wrap this up a little bit towards the end with respect to what's coming, what the timeline looks like, what we can expect in the near future. Before I really dig into this, I want to acknowledge Ben Edgington. He's one of our R&D team in Pegasus. He's a major part of the Ethereum 2 community. A lot of the content that I've got here has come from blog posts and articles that he's written, as well as some conversations with him. So if you want more detail, this is the man to go talk to, and I've got some links to some of the stuff that he's done at the end. But let's dig in. So what is Ethereum 2? I'm going to start with some design goals. You might go, well, that's a bit weird. Why are we starting there? Well, the reason for that is because when I did the talk last year, they weren't actually explicitly defined. And so in late last year after DevCon 4, Danny Ryan essentially documented these 5 goals. While they were essentially implicit in the design and everything that had been done to date, they had never been written down. And so if we just go through those, essentially we've got to minimize the complexity at even at the cost of some loss in efficiency, to remain live through network petitions, basically to select components that deal with our quantum future, utilize crypto and design techniques that essentially allow us to have a large pool of validators, and I'll explain a little bit more as to why that's important. And then lastly, to look at being able to utilize consumer technology like a laptop, potentially even your phone, to participate in an Ethereum 2 network. If we simplify those down a little bit, no pun intended, the first one is very much about simplicity. The second one's very much around resilience, longevity, security, and last but most definitely not least, decentralization. So let's start with going through each of them and look at simplicity. As it says, complexity is the enemy of security. And so when we're talking about simplicity here, what we're talking about is not just simplicity in terms of code, but also the concepts underpinning Ethereum 2. Blockchain technology sits at what is arguably some very complex systems, distributed systems, cryptographic systems, and game theory. And so the potential for a lot of the stuff we're working on at the moment to be very complex is quite high. The goal, though, for Ethereum 2 is very much the simpler the protocol, the better it is to be able to analyze and defend against oddities. And what do we mean by oddities? Where you might define something that's going to improve the system, reduce a problem, and it has the complete opposite effect. Right? By making this thing simple, we can start to look at and avoid some of those as we go forward. On the outside, though, Ethereum 2 may look quite conservative compared to some of the other things that are happening in the blockchain space at this moment. However, what I think is really important to keep in mind is that while it may look conservative, it embodies a huge amount of innovation. And some of that we'll touch on today. Resilience. We are hoping and expecting that Ethereum 2 will underpin a lot of critical systems in our future. Good ones example, payments, identity, possibly power generation, other areas of our society. We're hoping that Ethereum will be the underpinning piece of that. So it needs to be resilient. And it needs to be resilient for when, for example, a national firewall kicks in because of some geopolitical problem. What can the system do? What will happen? We don't really want it to shut down entirely because that defeats the purpose, right? The elementary theorem of distributed systems says that you can have two of these: consistency, availability, and partition tolerance. If we take the fact that nodes come and go, nodes can shut down, partition tolerance isn't really an option for us. And so what the Ethereum 2 is focused very much around is availability. And a good example of that would be random number generation. So Beacon Chain, which we'll touch on in a few seconds, one of its pieces that it needs to provide is random number generation for all the other components that are utilised. The gold standard in that, as far as I understand, is Dfinity's threshold relay. The problem with that is it doesn't deal with partitioning. Rendeo, however, while it has its limitations, does. And so the choice for the random number generation has been Rendeo. Okay? Again, we're considering what the resilience is of our system. Longevity. We want to be prepared. We want this thing to be around for decades. We know that at some point, quantum computing is going to make itself known. Come and say and knock on the door and say hello, and we're going to end up with problems in our security. Elements like Rendeo, for example, we believe at this moment are quantum secure. Other elements like signature aggregation, less so, based on what they're currently there. And so again, underpinning all of this is very much that, what I feel is a really good cryptographic design, which is that ability to swap out these pieces as we go along to deal with our future, where quantum exists and starts to break things down. Security here is not so much about security from a cryptographic sense now, but looking at making it harder for attackers to compromise and make our network behave unexpectedly. If you want to think about what we mean by that, in the current system proof of work, an unexpected behavior is what's called the 51% attack. Okay? We want to ensure that our system handles that. And so the design of Ethereum 2 is around ensuring that we've got large pools of validators. So making a system so that we can reduce the cost to participate and therefore have more validators. And we can organise into large communities that can then serve their various purposes like validation and attestation within Ethereum 2. By reducing the cost of participation, what that does is it actually increases the diversity of the people and the participants within our system. That by itself reduces the potential for collusion between them, right? It also means that your bad behaviours start to be more detectable, because if we all want to be colluding in that, everybody here has to do the same thing, otherwise one of us is going to put a hand up and say, hang on. And we have economic security built in to try and dissuade people from colluding. And by economic security, we'll talk a little bit about this later, but there is that concept of staking. You're going to stake, well, in this case, instead of thousands of ETH to be a participant, from a validation perspective, we're maybe talking 32 ETH. That's still a reasonable amount of money, but if we in this whole room have to collude to somehow successfully take control of a small part of the network and we get found out, we all lose. So that's called what they call slashing. And effectively, we lose all of our stake, and in the mainnet concept, that's the equivalent of going to your ASIC farm and setting fire to it. Right? You lose the lot, and now you've got to start again. The other thing that's interesting is more of a mathematical approach. Just want to check here, the minimum committee size is 128. And when we're talking out of a pool of validators measured in the several thousand, what that effectively means is to get 2/3 majority within a committee to actually do successful and serious damage, it's calculated at being about 1 in a trillion chance of that occurring. So just because we've now been able to increase the number of validators, we've reduced the potential. We haven't eliminated it entirely, but we've most definitely reduced it and added in other areas that help us to keep this thing secure. Last but not least, as I said before, is decentralization. Decentralization's been at the heart of so much of the Ethereum journey we've all been on so far, and it's most definitely still fundamental for Ethereum 2. Part of that is this whole concept of making the barrier as low as possible to participate, not just utilize the system. This comes back to that, reducing the validation staking from 1,000 ETH to 32. It's also, the benefits of removing, or the benefits of centralizing, as you might have with proof of work, where we come together and we set up a mining consortium, and therefore we have this ability for us to all make a difference by taking more control over the system, is reduced. There's more people able to participate, helps us reduce some of that. So again, underpinning all of this, everything that you want and need to do to run an Ethereum network should be based around community hardware. Laptop, small server farm, mobile phone, depending on how you define participation in that sense, they want to ensure that we can do this. And we'll talk a bit about that in a little bit further on about sharding, for example, which is essentially allowing us to increase our performance of our systems by a quadratic order based on this hardware, for example. Okay. What are the pieces that make up Ethereum 2? This is a quick snapshot. I'm not going to go into the detail of all of these, but just to refresh, we're talking about concurrency, how do we improve the speed and throughput of our network, consensus, moving from proof of work to proof of stake, state transition, peer-to-peer networking, and a stack of crypto improvements. And the actual components, we're talking about those, no surprises, sharding from that perspective, Casper FFG for our consensus, so moving to proof of stake with that. State transition, there's always been a desire to move to EWASM, and that's getting a lot more interesting, as I'll talk about when we get to one of the later phases. We currently use Dev P2P. It's got some limitations. There's been, again, a goal to move to a more known and more available standard, libp2p. And then finally, with the crypto improvements, I've talked about slashing, aggregate signatures, randomness, account abstraction, and many more that I'm sure will be added to as this journey continues. This is a diagram. If you've been to previous conversations, you'll know this diagram. It's one that Xiao Wei first created, and it's the architecture as it's at a high level of Ethereum 2. So we start with our main chain or mainnet. It produces and provides our staking, and then we move to Beacon Chain, and Beacon Chain provides coordination. This thing is busy. It's got our staking, it's got our slashing, it's got our Casper.
Is main chain Ethereum mainnet 1.0?
Yes.
Okay.
And we'll talk about that later.
Because I was going to say Xiao Wei's original diagram did not have main chain in it.
It did have the yellow one at the top, yeah.
Okay. Yeah, there you go.
So Beacon Chain is the one that's busy, and it's the most complex part of, in many cases, of this, because you've got lots of moving parts. We then have our shard chains, or various sharding here, and again, this is our economy of scale. And then last, we have our transaction processing down the bottom, our VM layer. Another way to look at these, and you'll hear this used a lot in different parts of the word, is the different layers. So our anchoring layer, which is our mainnet, coordination layer, as I've just said, Beacon Chain, our data layer in the form of our sharding, and then our execution layer, our virtual machines. So, happy to stop there for a few seconds before we move on to where we're at with all of this, but that's that top level view of Ethereum 2. And hopefully everyone's got a good understanding now of where we're at, so before we go into where we're going. Well, sorry, where we're going, where we're at, other way around.
Can I ask a quick question?
Of course.
Excuse my ignorance now, I'm not a computer programmer. So when I look at the data layer and sharding and that, in my head, I'm thinking, like you said, there's a lot of activity, a lot of transactions, and so I'm thinking security somewhat compromised at that level. Well, when I say compromised, it's not as secure. Is that a fair statement or assumption, or and then as you go back towards the main layer, you improve your security, but you reduce the level of transactions that's happening?
Well, one of the important parts is all the transactions happen at this layer. So there's no transaction processing happening in your coordination layer in that.
Okay.
It's all, so think of one of these
Yeah.
as mainnet today. And in
Oh,
fact,
I
in
see.
many ways, you can contemplate that mainnet may end up being, in fact, there was conversation around this at one point and thinking around mainnet becoming a shard in the future.
So potentially that top layer in yellow could become dysfunctional at this layer.
Correct.
Okay.
And in fact, part of the questions that still need to be answered, and I'll cover this very briefly at the end, is how does that look? What happens to mainnet in the future when Ethereum 2 becomes live and sentient? So, a year ago we had all this design and we now need to actually get somewhere with it. And so the group has moved forward with a phased approach, and there should be no surprises to people. Phase 0 is Beacon Chain. One of the most complex. It's the piece we need to get right to build everything else upon. Phase 1 is our shard chains. Now, importantly, as we go into this, it's not the fully operational sharding. Phase 1 is very much around trialing out what this sharding looks like and how this whole thing works. Phase 2 is down at the state execution layer, but then brings all of this back together. And it's at the end of phase 2 that we hopefully have an Ethereum 2 network up and running. So diving into the Beacon Chain implementation, Ben Edgington described this just recently. The Beacon Chain is a brand new proof of stake blockchain. It's the spine that supports the whole of the new Ethereum 2 system. It's the heartbeat that keeps the system live. It's the conductor coordinating all the players. A lovely bit of prose. One thing that people have maybe concerns about is, well, a conductor is a kind of a centralized point. The better way to think of it then is that we as the musicians have our own internal conductors. We all participate in the conduction of the symphony. So decentralization, as we said, is still at the heart of all of this. But you can't take away the fact that Beacon Chain is a very heavy bit of coordination for all of this to succeed. And this is the sort of stuff that it has to deal with. Okay, so it's managing our validation and our staking. So our validators, it's involved in nominating the block proposers for each of the shards. It nominates and organises randomly the validators in the committee who then validate those blocks. Applies consensus rules. It's associated with rewarding the proposers when blocks are successfully added. It's also the penalising system for when people have done the wrong thing. And then obviously it's our anchor point where we can then communicate to other shards that a shard is, for example, finalised. So it's our finalisation element within this. Let me go back one. What it's not is it's not programmable. It has no transaction processing. Unlike so one of the things while we say it's Beacon Chain and we think of our blockchain, it is not a blockchain. It doesn't actually have transaction processing in that sense. It is a blockchain in the sense of blocks and tying stuff back finalisation wise, but all the execution goes down in the layers.
So when you say it's not programmable, you have a handful of functions that it does, and it's like, that's all it does.
Mm-hmm.
Okay.
That's the staking contract?
The staking contract at the moment is actually going to be in mainnet, and it communicates to blockchain the fact that something's there, and I'll talk about what that looks like. Interestingly enough, preempting that, it's a one-way process, which is an interesting thing.
So could you think of it as it does do transactions, but all the transactions are not user transactions, they're more administrative control stuff, like for instance, Peter's done something nefarious, let's / Peter's, stuff, and so that
Correct.
will go through.
Yeah, it's a very different transactions to the way we think of it today in terms of I'm transferring ETH to this person or I want to run this smart contract. So the smart contracts, for example, don't exist at this layer.
Yeah.
When Beacon Chain was first, or when Ethereum 2 was first being considered, you have this concept of both proof of stake validators and sharding validators. And part of the big thing that occurred middle of last year was this recognition that why can't we just combine these? And the original idea and design was going to have two smart contracts on mainnet, one for staking for proof of stake and one for essentially being a participant within a shard validation. Mainnet's already quite heavily processed. In fact, the whole reason we're coming down with the idea of Ethereum 2 is to improve things. And so that was where the initial idea of separating Beacon Chain from mainnet happened. The idea was we wanted to move that processing off this struggling system, or potentially struggling system as it becomes more and more adopted, and bring it into something dedicated specifically to do this role. Okay. The added value of that was that ability for us to combine the validation pools. What that meant was we suddenly were able to bring the staking contract down from, as I said previously, 1,000 ETH to 32 ETH. And as we talked earlier in terms of security, having a large pool of validators increases our security purely through the mathematics associated with that, right? Looking at it from a processing perspective, main chain or mainnet at the top, the idea being that you have a deposit contract, 32 ETH essentially gets you entry to the pending validators part of this. Beacon Chain will then randomly select a collection or a committee from that pool. They become the active validators, they then vote on blocks, and ultimately over a period of time finality occurs by having stuff written back. As I mentioned earlier, what's really important to realise is this is currently defined as a one-way process. Your 32 ETH effectively transfers from ETH1 to ETH2, and there is no current process for which you can return. So what this means is if you choose to no longer be a validator in the future, your ETH would then be transferred to one of the shards in the same way. So going down that. Now, of course, if all this goes horribly wrong, we're going to have to work out how we then allow people to put money back. Let's cross that bridge when and hopefully it never occurs, because this is kind of our future we're looking for. But keep that in mind when you look at some of the goals for Go Live that are part of the Beacon Chain when we get to that. So, brief overview of what Beacon Chain is.
So just a sec, so if everyone is putting in, like if you put in 32 ETH and I put in 32 ETH, a whole heap of other people put 32 ETH in, and to all be validators. At the moment, if I put money in as a miner, then my hope is that I'll create some more ether it's the idea that you'll create more ether by being a validator somehow?
Yeah, but it'll be in the ETH2 world. So yes, as a validator, you get, as a proposer, you get rewards. So there is that concept of both rewarding and slashing. So you stake, depending on how much you stake, a percentage essentially comes back to you from a reward perspective. Okay, so bigger the stake, more reward, more risk. Of course, as we said, the challenge here is that all of this only really starts to pay dividends when we get to those, we're now actually transacting, and Ethereum Ether is actually Ether 2, not Ether 1.
Okay.
So you really are buying into the Ethereum 2 thing, and you're
Yeah, absolutely.
You're putting your 32 ETH on the line that phase 2 will happen and everyone will move over.
Yep, that's pretty much what it is. Yeah. So, where are we at now? A year ago, June last year, the whole concept that we've just talked about was conceived. A year less a day, the specification for Beacon Chain was frozen, and that was at the end of last month. So while it will continue to evolve for sure over time, we've frozen and stopped where we're at the moment. Why is this really important? Well, it allows two things to happen. The first of those is it allows us to subject this whole specification to formal verification, and an organisation called Runtime Verification is starting and going to be doing that process. As I said up here, that involves translation to a special language that allows us to then, prove correctness. The other piece that's really important is it gives all the people who are currently developing clients, and Beacon Chain has different clients in the same way as Ethereum does. We have Parity, we have Get, we have Pantheon, etc. You have a similar system here, and so there's been a number of people working on this, and this gives everyone now that chance to say, right, the goal is no longer going to move. We all need to build this thing, and then we need to actually make them play nice. And so interoperability is the next big step that we need to overcome. To give you an idea of who's doing that at the moment, there are 9 client development teams out there at this moment in a variety of languages. Some new, some others that have been in the market for a little bit. Can't help myself but point out that Pegasus has got a horse in this particular race with Artemis. Of the 9 climates up there at the moment, 3 of them already have public proof of concept test nets. Nimbus was the first one, Lighthouse second, and Prism just relatively recently have got test nets up and running. Okay. And test nets, of course, are part of how we get this thing to a point where we can finally flip the switch and make it happen. Continuing on this journey to interoperability, however, we now need to make sure that all of these clients are doing exactly the same thing. One client doing something wrong and getting a bit out has the potential to cause a network split. What that means, as an example, was I think November 2016, there was a difference in how a piece of processing occurred between Parity and Geth, I believe. Geth had decided to do it one way, Parity did it a different way, and we had a network split event that required some patching and everything got put on hold for a period of time. So it's really vital that these things do the same thing. To make sure we're at least working towards that, there's a common set of reference tests. And what's interesting is the specification has been written in such a way that it can be generated, it generates test code that can then be run against them. We also need to do fuzz testing, and for those who haven't heard what fuzz testing is, it's when essentially you throw a stack of broken data at a system deliberately to find the corner cases and make sure it behaves. Once we get these done, right, we can move towards that, let's start making sure that these clients all behave. Debugging in a distributed system is notoriously hard. And so while we are going to be moving towards using libp2p, at the moment, we're using this rather fun named lightweight protocol called Hobbits. And the view there is it basically allows us to start to work out where we have interop problems between the various clients. Continuing the journey, we have proposed that in September of this year there will be an interop lock-in in a quote-unquote remote cabin in Ontario. If anyone knows what that film is, you'll all hope that that's not what it turns into. Basically, nobody leaves till we have interop is the goal. But the most important point, yeah, exactly. The most important point of this is that we need to get to a point where we have enough interop that we can then have a full, long-lived public testnet. So, go live conditions for Beacon Chain requires the following, and you'll now see that buying into this whole process as we talked earlier. There needs to be roughly 65,000 or so validators for this thing to have a chance to step up, and that equates to roughly 2 million ETH.
So that's, I was thinking that's about, what, $500 million. So essentially, we need $500 million committed by various people generally.
Who genuinely believe Ethereum 2 is going to happen.
To go forward.
Yep.
You get there, you've got a lot of political pressure for the rest of Ethereum 2 to roll out.
Yes.
Yes. Yes.
Well, at least you have had since the ETH Classic failure.
Yes.
Yeah, $500 million worth of, come on.
Yeah, it's a whole lot different to the kids in the back going, are we there yet? These ones have got some big sticks. Sorry.
What's that as a fraction of the whole collection of each?
I don't actually know what the total ether is.
Yeah, that's
still a countable number of percent, right?
I can tell you in about, it depends on the network speed here, but yeah, come on.
Fairly small percentage, I think.
Yeah, I thought we're at
single
20.
digit sort of.
Yeah, no, we're
single
at,
digits, not fractions of fractions.
yeah,
I don't know.
so the total market cap of Ethereum at the moment is 22 billion. So yeah, it's what, 5? Is that?
No idea. I'm not going to do that in my head.
Yeah.
I've had some really early mornings this week and some really late nights trying to read this. Sorry?
Market cap.
It's a quarter of a,
Yeah, I'm getting.
no, 2.5%, isn't it?
Yeah, no, that's the supply 100 million ether, but the cap is as a 21.9 something billion.
But is it
at today's rate?
Yeah, isn't that the price times the amount of issued ether?
Yeah,
Yes,
yes,
market
yeah,
cap.
yeah.
So now, I've got a question that's not related to percentage, I'm hoping. Go for it.
Yeah, is there a time limit? Right?
On this working,
Yeah, like you have to have 5,000 validated? Do you have a time limit as well?
No, it's basically a case of we want to, until we get that, this is one of our 2 conditions we need to go live, and I'll talk about that in just a second as to what the next steps are. The other one that's associated with that is we need 2 to 3 production clients. So we don't want to go live with just one Beacon Chain client. We need at least 2, preferably 3 different clients that are out there making this thing work. Justin Drake's definition is essentially an important consideration, which is why this interopt is really important to make this happen as quickly as possible. We want something running for long enough in a testnet environment to see if this thing's going to stand up, right?
Yeah.
So is there any plan for an upper cap on participants with the 32, as in, will it get to be too many participating such that the stake or the return becomes uneconomical or
I haven't heard of one, to be
That's
honest.
not
I mean,
the fun,
when I first did this last year, the number, that equates to about 65 point whatever, 65, and I can't remember the next 3 digits, 1,000 validators. Last year, I think they were talking originally around 300,000 validators was what they were ultimately thinking was a good, large quantity of validators that increases that security.
But that's the thing about the percentage. What percentage is it? You have to tie up 2% just in running validation. That 2% is not available for doing any actual thing at all. So presumably people want to keep some large fraction of ETH working.
Yeah, and we would hope that over time, once this thing is up and running, you know, validators may come in, stake for a period of time, gain some rewards, step back out and take their ETH. As I said, at the moment, once it goes live, yeah, exactly.
you're in the well and you can't crawl out.
Yeah, right now we're just expecting you to jump in the well. So, you asked a question about timelines. Staking contract is due to go through a public launch event at DevCon in Osaka, which is in October. The reason they want to make this very public, of course, is because we're going to be asking people to give 32 ETH. And so we want to make absolutely sure that that address for that contract, everybody knows what it is, and that the scammers make it just that bit harder for them to do something nefarious to everyone.
I imagine there'll be a bit of review on that contract.
I suspect so, yes. I would hope so.
It would be hard to steal the ETH because it just immediately burns it. So it's not actually a high value target.
But it depends when they say.
No, but
when
passing
people say
someone else
burn, I guess
against the
they don't
contract and getting it
out.
wrong.
Have you ever met someone who spray paints stuff on the side of a wall or just wants to destroy something?
Oh, it's a fun target. It's just not a high value target.
I'm not sure that's the disadvantage you think it is.
Moving on though, you'll hear this date, January 3rd, 2020. Why is that the date that is being suggested for the Genesis block event for Beacon Chain? Because that's 11 years to when Bitcoin's Genesis event occurred. So there'd be a lovely story associated with that if we can make Beacon Chain there. But given what we've just talked about, not only do we need the 2 million ETH, we also need a long-running testnet with at least 2 to 3 production-level clients operating in that. We still have interopt, and we've only just locked down the actual specification. That might be a little optimistic. However, the general community feel is that sometime in Q1 of next year, we should see Beacon Chain become live.
So March 31.
Sorry?
March 31, rather than February 3.
March 35.
Yeah, maybe March 38. I don't know. It's a bit hard to tell. But that's the goal. That's what people are aiming towards. It's worth realising, though, that a year ago, Beacon Chain didn't exist. So there's a lot of people getting heavily involved in this. They see the value in this from a technological perspective, a lot of political, in the sense of people working towards achieving the lockdown of the specification. Okay? That's just phase 0. Fortunately, the story for phase 0 is a lot better than maybe the next phases, because they're a little less clear. Phase 1 is about sharding, and so I want to talk very briefly again what that means to give everyone a common context. You'll occasionally hear the blockchain performance trilemma, the scalability trilemma, but effectively what it is that we have these 3 competing pieces. We've got scalability in terms of both transaction processing, number of people who have to participate, decentralization, which gives us that censorship resistance, and obviously security, the immutability of the ledger. And you can only pick 2. So the two that mainnet is very much focused around is decentralization and security, which is why we have this scalability issue of transaction throughput is relatively small compared to what we would like for a commercial system. The goal of sharding is to overcome the third one there and actually give us that scalability. So what is sharding? As I've kind of alluded to and made comment in one of the earlier slides, it's essentially breaking up our transactions across effectively full running little shards or main, blockchains in their own right, which gives us that quadratic increase in our processing power, because essentially it's a single throughput under normal circumstances. What it also does, it allows each of our shards to share the same proof of stake consensus mechanism. So they're still going to be doing true proof of stake. Beacon Chain is Casper FFG, which is proof of stake and proof of work at the moment. This allows us to get to full proof of stake. Let me just double check what my next one is. Yes. So finishing off. Sharding has 3 nodes or 3 elements associated with it, and we've mentioned some of these already. There is the block proposer, right, which is the person who is responsible, the node responsible for proposing the next block. They're the one that is rewarded for that. You have your attester nodes, which is that random selection of people who then vote on and agree to this being the next canonical element in our chain. And then you have executor nodes, and there's a belief that ultimately those two will be the same. Both an attester and an executor will probably be the same. But that's our 3 nodes that represent the sharding. Phase 0, however, is not all of that. As I mentioned earlier, phase 0 is an intermediary phase. Phase 1 is an intermediary phase. Think of it as a trial run. We need to see how this is all going to work with 1,024 shards, how basically we're going to, the construction, the validity, consensus of these data shards. It's just going to be data at the moment. It's just going to be testing out the water and making sure that this thing will work. The execution layer doesn't exist at this point. That's in the next phase. So at the moment, what we're going to do is test it all out, make sure it works. Beacon Chain will treat these things as just data bits. It's not going to be doing anything specifically with it. Validating this thing's going to work.
Will that be a valid test of it then? So the whole idea is let's test it out, but if testing it out isn't...
Well, part of the testing that we're going to be doing at this stage, if you think about it, is Beacon Chain is fully operational, right?
Yep.
You're still going to need to be able to propose something, have a proposer who's going to need to propose things. You're going to need to have those random selections of committees that then vote on that. You need to then have the communication back and forth to ensure that things are being finalised correctly. We'll talk about some of those other pieces in a second. What you're not going to be able to see is whether or not we have that scale of performance, because until you have your transaction processing layer, you're not going to be able to do that.
Isn't the thing the proposers would be proposing would be the transactions that won't come until phase 2? Because they'll be proposing transactions to execute upon the data, but if do you see what I'm getting at?
Yeah, I know. Yeah.
I don't know. Maybe I'm missing something. I don't know.
Yeah, I'm not 100% sure. The specification, while it's getting close, it's outside of my skill set to be able to read that and understand it, to be perfectly honest, and it's still potentially in flux. But at this moment, everything I've read and everything I've been able to understand about this is this whole phase is very much around validating the comms, validating that the ability to push things out to shards is going to work, that Beacon Chain is going to be able to do what it needs to do. What it's not going to be able to do is validate that that sharding itself, the individual shards will do what you hope once you actually bring up the transaction layer.
Okay.
Yeah, it's basically testing that you can say the latest block on this shard has this hash. How you got to that hash, it doesn't care. Right? So, your shard validators basically collude and say, setting the value to 100. Great. Hash it, send it up to the Beacon Chain. The thing is more about the coordination with the Beacon Chain, not the processing of transactions.
So you can't test that the actual execution of the shard layer does anything useful, and you also can't test that you go from one shard to another because the shards are meaningless. They're not real stuff.
Cross sharding is still something we need to
at that level. Yeah.
Yes, correct.
So does that mean that somewhere in the system there is a set of metadata at the Beacon Chain level that transcends the block metadata?
Yes, so that's the attestations that
Yep.
validators put up. They attest that this shard has this hash, this root hash, basically.
Right.
And that then gets kind of embedded into the beacon chain, which provides the finality.
And so the
Not
beacon
like-
chain keeps the state on that metadata. Is the beacon chain a state machine for that metadata?
Not entirely. It keeps a window of attestations, but it's not staked in the sense of like mainnet has the world staked.
Yeah.
And then it gets complex and hand wavy.
Yes.
I can't tell you in any more detail, so please stop asking.
These are not the questions you're.
Yes. These most definitely are not the questions for me, let's put it that way. We've kind of already covered a lot of what's up on this slide as it
I feel
is.
better if I felt that somebody knew the answer to that question and not.
I suspect they did, and I can probably point you at a video that will make you just as confused as I was, but maybe feel better because you might understand it more. That does come back to what you were just talking about briefly as well, as this concept of cross-linking, right? So periodically writing back that to essentially the beacon chain, which is going to record that when a beacon chain block is finalised, the shard is considered finalised, right? Which allows us to then move towards that idea of cross-shard. You know, knowing that this shard is finalised means that I can then take that information that I need from that shard, right? And essentially we're talking about sets of signatures, so this is that aggregate signature component we talked about briefly earlier, being able to have a process which allows us to have a large number of signatories, attesting to this thing, but something that we can then quickly validate, as opposed to having to go through and do all the individual signatures and validate all the individual signatures.
I have a question. Will you be testing like the slashing at this point as well?
Very
And
good
if
question.
so, who's going to volunteer to sacrifice their each?
That's a really good question. I actually don't know. Considering slashing is part of the beacon chain component, I would hope that it is part of the specification in there that's been done, but I haven't looked into it. So it's a very good question. Something I can ask.
Presumably you tested on the test net.
Yeah.
The assumption is, the whole underlying assumption, you don't have to do slashing because there is no big incentive to behave in a way that makes people want to slash you, right?
Yeah.
Because if that assumption is wrong, we've got a bigger problem than
Yeah,
does
yeah.
the slashing
If you're
work.
happy to watch, a lot of ETH get burnt, yeah, okay. But yes, that's what you have a testnet for, right? Ultimately, free, make it work, validate it.
Okay, so testnet is actually, in this case, it's like, it doesn't matter.
Yeah.
Correct. So, yeah.
Free.
Oh, I have ETH, they'll put it in.
Yeah,
Free
test.
to test slashing.
That's fake, yeah.
Right.
Yeah.
Testnet is a private chain that's set up, which runs on top of the same infrastructure, the same software, but has funny money involved in it. Right.
Yeah, and there's a number of ones for mainnet already. So this again is why it's really crucial that we have a beacon chain testnet up and running with clients, so we can run through these various scenarios. But to do that, we need that interop.
People will accidentally volunteer to test slashing, which is that's what first triggered it on the test net that's been running. A few weeks ago, I think was the first one that got slashed. It was because they had high availability set up, that if this node went down, the next one would start up, and the next one started up before this one went down, sort of tested for 2 different blocks. And that's a slash.
Boom, you're gone. Yeah.
Oh, that's cool.
Okay, so what's important to recognise here is, unlike phase 0, this is still all in a state of flux. There's lots of stuff happening around this. The spec is getting quite close to finalisation, but unlike phase 0, which has been finalised, this hasn't. Okay. Phase 2 is that bottom one. This is where the rubber hits the road and we actually start to get something realistically happening. And to do that, we want to talk very briefly about the thing you'll hear a lot of. Apologies for those who've been to at least 2 talks of mine that had EWASM mentioned. I'm going to define it briefly before I actually say much more about it. There's a thing out there called WebAssembly, and Ethereum WASM or EWASM is just that, with some changes to WebAssembly. So it's the Ethereum flavour of WASM. And what's really important, what the major changes there is we need to make sure that it's deterministic. And by that we mean that we need to remove all non-determinisms. That allows us to then support metering. Okay. Metering, for those who played around with mainnet and any sort of under the cover yellow paper goodness, essentially allows us to all agree and calculate what the transaction cost is of a contract, for example. Okay, and one of the biggest problems you have from EWASM or WASM is that you have floating point calculations, and so by getting rid of floating points allows us to then move forward with that, as well as costing everything out. So basically, being able to calculate as opposed to agree on what the actual gas costs are for various transactions or various opcodes.
I thought that there are, I'm certain there are international standards for floating point that says this number, which defines exactly how to do floating point, and so everyone comes up with the right answer.
And if CPUs implemented it properly, we'd be all for them.
Yeah, therein lies the problem. Theory and practice is just a little out.
Okay, that's very frustrating because floating point would be really helpful.
I know.
So the reason for getting rid of floating point is not that we couldn't make a standard that we agreed.
Okay. Hello, everyone. We're back. So the internet broke whilst we're at the meetup, but we thought that we'd re-record the second half of the talk. So, Brett, thank you for agreeing to,
No problem, Peter. So let's dive back into where we finished, which is at the end of the first couple of slides on phase 2. Okay, so we've talked a little bit about EWASM, and now we want to get into what phase 2 looks like. And as we said earlier, phase 2 is where we start to get into the transaction processing. So a few months ago, the view of what phase 2 looked like was basically like this picture. I really wanted to have a picture that looked a little bit more like fog with a big train coming towards us, because we knew it was coming, but we didn't know what it was. But earlier on this year, we really didn't have a good definition of what phase 2 looked like. And then Casey DeTrio at the Scaling Ethereum conference in Toronto was able to break the impasse on that with a talk that I believe was called Ethereum 1.2 Done. And it got people thinking about how we move forward with this. And what was decided was that we wanted to minimize the role of the blockchain in executing transactions. And the way to do that was to introduce a new concept called execution environments. What we're doing here is essentially abstracting away the processing that exists in an Ethereum 1 environment today. If we look at Ethereum 1 today, we can think of it as a single execution environment, the EVM, with a few small differences, and that is that it's written into the protocol of Ethereum that every smart contract must be executed by the EVM and be charged gas. And then in addition to this, there's only certain cryptographic signatures and replay protection schemes that are allowed. With Ethereum 2 and the execution environments, what we're looking at, however, is code written in EWASM that will effectively run as pure functions, as the goal of EWASM is, that operate under their own rules and, most importantly, are optimized for their own purposes. So what do we mean by an execution environment? What examples do we have? So we could have examples, EWASM smart contracts, anonymous token transfers. So instead of having to execute with gas and have account information in there, we could have execution environments explicitly abstracting away from that and allowing us to do those transfers in a more anonymous way. EEs for a new smart contracting language. One's optimized for high capacity plasma chains, for instance, or even ones that are designed for enterprise, so introducing things like privacy and permissioning. With the EVM today, another difference we want to think about is what is happening with respect to state. So right now, when you execute a smart contract and a set of transactions, the result is the Merkle root written back to the block. In order for an EVM transaction to actually be executed, all nodes need to have access to the state of the entire blockchain. And one of the things that I've talked about in the Ethereum 1.x presentation that I did earlier this year was about state root or state pruning, which is that attempt to kind of reduce down the size of our state. With EEs, however, what they're looking at is actually no longer storing state in the EE, but actually having it be something that needs to be provided to it. So as an example, if I want to do a transfer of a token to somebody, then along with the transaction, I also need to provide a proof, such as a Merkle branch, of the balance of that transaction. So no EE has an independent idea what my balance is because it doesn't actually store it. However, as we've gone on this whole journey, including especially this last section, there is a lot of questions still open. So while in phase 0, we were very much, we've locked down the definition, we're moving rapidly towards a delivery stage. Level 2 or phase 2 and phase 1 are both still in that level of flux as we've talked about. And so we've got questions like how will state rent work? Whether or not we have immediate execution or delayed execution. Will validators be executors? Will executors be different to validators in for example, sharding? And of course, how will cross shards work? There's a lot still left for us to actually work through, but it's massively focused upon, and so a lot is being done in recent times. So we've gone through the phases. The question now is where next? The timeline, it's been a year since Ethereum 2 as we know it today was first conceived of. And while the phases I've talked about today have been planned in many ways to look sequential, they are actually being worked on in parallel. So work is being done on phase 1 and 2 as we speak, even while phase 0 is still working towards its delivery. And as I said, it's nearing that stage. It's worth taking a brief stop for a minute just to reflect on where we've come from and where we are and how much has happened just recently. In 2014, Vitalik did a post where he said that we should expect the second version of Ethereum to be released in 2016. In 2018 was when all of this really started to come to a fore. And as I said, that's when Ethereum 2 as we see it today was conceived and finally designed as what we want to do. In a year, we are already looking towards the delivery of the first part of that. So in September of this year, we've got our interop lock. In October, we've got a staking contract launch and phase 0 delivery sometime early in 2020. While phase 1 and 2, we don't have dates for and we don't know exactly when those timelines are, so much is happening in this last 12 months that you can expect to see this just only increase in speed. And of course, there's, as we've talked earlier, a lot of incentive after the staking for this to actually get finished. I want to leave you with just a view of what the network is going to look like as we go through with this, because of course there's still the question of what happens with Ethereum 1. Phase 0 is going to continue to have 2 active chains, as I've talked about and referred to often, Ethereum 1 and Ethereum 2. ETH can be migrated from 1 to 2, but it's a one-way migration, hence the impetus to get Ethereum 2 out there. Phase 1 will continue this with both 1 and 2 operating in parallel. And then finally, phase 2, we have to answer the question of what do we do with Ethereum 1? One of the things that's being considered is Ethereum 1 could be an Ethereum 2 execution environment. In other words, an EVM in EWASM. Along the way to be able to present this today, I've had a number of references of information that you may find of use for yourself. The Ethereum 2 specifications are available there on the Ethereum GitHub. I've mentioned, and I must again thank Ben Edgington for a lot of the information I've been able to utilize today. Ben has a regular post that he writes called What's New in ETH2. If you're interested in knowing the latest updates and what's happening in the overall community, that's definitely a good source of information. ETHHub has a good definition of the Ethereum 2 phases, as well as a number of other areas around that. It's a community-driven documentation site. And with that, we come to the end of the journey. That is the current Ethereum 2 state. And we leave it with questions. And because we can't... Oh, you have a question. Okay, go for it.
Yeah, so with EWASM, you were saying that you don't have the ability to, is it access state? So is it a pure function in that you have parameters come in and then you have results go out?
So not EWASM per se, but the execution environment. So one of the things that they're looking at, as we said, is having these execution environments. And what they're looking to do is actually say that everything that the execution environment requires to be able to do its job needs to be passed to it, and that includes the state.
Okay. So I guess there could be a execution environment that runs Solidity then, and it sort of takes the contract state as input and then outputs the updated contract state.
Correct. That's my understanding, yeah. But like I said, a lot of this is still so much of phase 1 and phase 2, and phase 2 specifically, like I said, only a couple of months ago, none of this even existed. It was still very much a, how are we going to deliver on the promise of the transaction layer providing the throughput that we need for Ethereum 2 to really make its difference? And what do we do from a scalability perspective and longevity perspective? Harkening back to some of the goals we talked about at the beginning of this presentation.
Mm-hmm. Yep. Thanks.
Cool.
I don't think I've got any more questions, but Adrian has got a burning question that he's been always wanting to ask.
Yeah, thanks for setting me up, Peter. I really don't.
I do recall that there was a few other questions, but unfortunately I can't recall what they were at the moment.
Yeah. Oh, well.
Okay.
Yep. All right. And then I think in the next slide, it's about what's happening at the meetup. Yep. So we've got Hopper Down Under conference next week, and that's a conference in Brisbane. You should register for it. It costs, I think it was $900-ish, but please check the page there. We've got a talk on the Enterprise Ethereum client specification in 2 weeks' time. After that, I'll be talking about sidechain pegging. Pegging is about, you've got a private blockchain and you want to secure its state and prevent state reversion on that private blockchain by leveraging the security of Ethereum mainnet. And then Sandra is going to talk about how you can facilitate invoice financing using blockchain and Bayesian networks. Yep. All right. So thank you, everyone. And the next video will be in about 2 weeks' time.